What I'd like to do now is go ahead and demonstrate a private VLAN configuration, and let's use actual Cisco gear. Let's use the switches and routers that we find in the routing and switching rental racks at our rack rental partner, Proctor Labs. So let's go ahead in this particular scenario and let's create a private VLAN infrastructure across a couple of Catalyst switches. Now remember, you want to be on 3560s in order to do this particular walkthrough. If you want to follow along with me, maybe you want to go ahead and watch this video several times and follow along with the configuration, make sure you're on 3560s where the private VLAN configuration feature is supported. So what we're going to do is we're going to go and we'll pick on switch 2. We'll trunk it, make sure it's trunking over to switch 3. And then what we'll do is we'll have our routers in the scenario. This will be R6. We'll have R1 off of switch 2. And then off of switch 3, we'll go ahead and have our R4 and our R5 device. Now, what we will do is we'll go ahead and, let's have R6 be promiscuous. Woo, sounds sketchy. So R6 is our promiscuous device. We're pretending in this scenario that R6 is the default gateway, right, to get off the private VLAN infrastructure. Then what we'll do is we'll have R1 and R4 be in a community VLAN together, and then we'll have the R5 device be in an isolated VLAN. So what we'll have is R1 able to communicate with R4 in their own community VLAN. R5 will only be able to communicate with the promiscuous device R6. And by the way, R1, R4, and R5 should all be able to communicate with R6 because it will be their default gateway in this scenario. So there you have it. Notice that we can really test this feature and we can really practice with this feature with just 2 switches that support it, 4 routers, and we can really practice with all of the elements of the private VLAN configuration. What I did prior to this particular video is I just did some setup behind the scenes so you didn't have to watch, everything be configured like host names and all that stuff. I gave the routers IP addresses. One of the nice things in a scenario like this to make sure that everything's going to work just perfectly is you'll want to go in and you'll want to make sure that you have full connectivity without any private VLAN infrastructure, right? So R1 can reach R5, R1 can reach R4, R1 can reach R6. Yeah, beautiful. We've got full connectivity. Everyone is just in a standard VLAN. And sure enough, everyone's got connectivity with everyone else in this standard VLAN type of an environment. In fact, let's take a look at that. If we go to switch 2, for instance, and we do a show VLAN brief, we can see that there is a VLAN 10 that I created, and this is the port going out to R1, this is the port going out to R6, and they're in that standard VLAN structure, and that's why everyone can communicate in that VLAN 10. We're now going to dramatically alter that with a private VLAN configuration. Since we're sitting here on switch 2, let's start our configuration here on switch 2. First thing, don't forget, we got to be in transparent mode in order to take advantage of the private VLANs. So I go into transparent mode. I then create a VLAN 600 and I say that this is going to be a private VLAN of type community. We then say, okay, VLAN 400. Our VLAN 400 is going to be a private VLAN, and it is going to be a type of isolated. And then finally, our VLAN 200 will be of the private VLAN category, and it will be our primary VLAN. We now do our private VLAN association, and we say, okay, we've got the private VLAN of 400 and 600 that are associated with this primary VLAN of 200. So notice, very simple, not rocket science here at all. This is our first step. We go ahead and we define this private VLAN structure on the device. In fact, you would want to leverage this for the other device, wouldn't you? You could do a show run, and in your show run output, we should see this configuration, and there it is. And we can go ahead and grab that to our clipboard, because that configuration, of course, needs to be mirrored over on switch 3, also participating in this private VLAN structure. I'll do my VTP mode transparent over there, and then I'll simply paste in the appropriate configuration on this device. And over here we see an error message, invalid private VLAN association between our, oh yeah, okay, look at that. The order of operations here got in trouble, right? It's saying there is no VLAN 400. Okay, we can use this command now that VLAN 400 is actually created down below. All right, no problem. So all we need to do is go into VLAN 200 and then paste that command in. All right, great. So we ran into a little order of operations issue there. No big deal. Okay, so gosh, we're off and running now. We have our private VLANs defined in these two different devices, and now we're ready to go. And that was very simple, wasn't it? And now we're ready to go in and manipulate the port configurations. So let's go ahead and do that now. Hey, why don't we just stay right here on switch 3, since we happen to be here on switch 3. All right, let's go into global configuration mode. Let's go to interface fast Ethernet 0/4. And let's go ahead and make the configuration here for one of our community VLANs. We said this particular R4 we want to put in a community VLAN with the R1 device over on the other switch. So what's our correct configuration for a community VLAN member? Well, first up, we're going to go ahead and say switch port mode. And do you think we would say private VLAN? Sure, you got it. And this is a private VLAN type port of host. We then go in and say switch port private VLAN host association, and our community VLAN was 600 and our primary VLAN was 200. So we simply say 200, 600. Notice you would probably want to write these out on scratch paper, right? What's the primary VLAN number? What's the community VLAN number? What's the isolated VLAN number? Because you certainly don't want to make a mistake in that particular logic. Okay, great. So let's confirm do show run interface fast Ethernet 0/4. And we've got that old access VLAN command in there. Let's get rid of that. No switch port access VLAN 10. We'll take care of that. All right, great. Let's bop over to the R5 port. The R5 port is going to be our isolated port. It doesn't want to play with anybody. All right, so we're going to say, first of all, no switch port access VLAN 10. We know that's in there. And then we can use our up arrow here to say switch port mode private VLAN host. Great. and then our host association command, and this time it's 200, 400. All right, show, run, interface, fast Ethernet 0/5. Let's make sure that looks good, and it does. Awesome. Let's make sure we're trunking over to switch 2, and then I think we're done here in switch 3, and we can go over to switch 2. Show, interface, trunk, and yes, great. We have a trunk link over to switch 2. Let me make sure that switch 2 by doing a show CDP neighbors and making sure that is switch 2 over the fast Ethernet 0/19 trunk, and it is. Okay, great. We'll save all that hard work and we'll move over to the switch 2 device. All right, here we are on switch 2. On switch 2, we know the VLAN infrastructure has been defined. We just got to go after the appropriate port configurations. All right, interface, fast Ethernet 0/1, the R1 device. This is going to be in a community with R4. We say no switch port access VLAN 10. We take it out of there and we say switch port private VLAN, and we say host. And it says incomplete command. All right, what did I do wrong here? Switch port, how about switch port mode? Yeah, that would be better, Anthony. Switch port mode, private VLAN, host. Great. And then we do our switch port, private VLAN association command. And let's make sure we get this right. The primary of 200 and the community VLAN of 600. And let's check the syntax here. Association host. You know what? I'm messing this up, aren't I? These commands, don't be afraid to use context-sensitive help. And that's what I'm not doing here. And that would remind me of the correct command. Look at that. Yeah, don't be afraid to use context-sensitive help. So the correct command here, switch port private VLAN host association 200, 600. Whew! I think I got it done. Show, run, interface, fast Ethernet 0/1. Okay, that looks good. That should be in the community VLAN with the R4 device. And now finally, the Promiscuous port. Interface, fast Ethernet 0/6, no, switch port access VLAN 10, and now we're ready for the Promiscuous port configuration. Switch port, mode, private VLAN, and before we were saying host, but this time it's a Promiscuous port. And we issue the syntax switch port, private VLAN, mapping, and we say 200 is our primary VLAN, and 400 and 600 are the sub-VLAN structures, if you want to use that language. We'll do a show, run, interface, fast Ethernet 0/6, and we can see that those commands are in the appropriate interface. We save all our hard work, and of course now it is time to test our configuration. Testing is going to be really simple, isn't it? Everybody should be able to communicate with R6, the Promiscuous port, and then there should be limits in the communications that are possible. Let's go over to R1. R1 should be able to communicate with the Promiscuous device R6 at 10, 10, 10, 6, and it can. R1 should be able to communicate with its community member R4, and can it? No, it can't. So we've got some troubleshooting to do there. All right, interesting. It cannot communicate with its other community member. And by the way, you'd want to, do the ping twice just to make sure that we have convergence in the topology. And yeah, we are in big trouble there. So R1 can communicate with the promiscuous device, but it is not able to communicate with its other community member. Sure enough, it's not going to be able to communicate with the isolated private VLAN member either. All right, so let's look at switch 3. Let's go over to switch 3. We get some bonus troubleshooting here. Oh, let's go, over to R4. R4, can it reach the promiscuous device? Ah, and we can see this must be where we are having an issue, right? Because it cannot communicate even with its promiscuous device. Can R5, the isolated participant, can it communicate with its promiscuous device? No, it cannot. So it's on the issue is with this remote switch 3, if you will, remote from the promiscuous port. Are we trunking properly? And we got to go to the switch to find that out. We're trunking, but it's this negotiated inner switch link connection. Can we do private VLANs with ISL? I'm really not sure, but that's the first thing I want to troubleshoot. So I'm going to say interface fast Ethernet 19, switch port, trunk, encapsulation, .1Q. We see it come down. We should see it come back up. We'll take a look at our show interface trunk output, and we are now an 802.1Q trunk. All right. Now, without doing anything else, I'm going to test. Can R4 reach its promiscuous device? And again, I'll ping twice in order to make sure we have, convergence of the topology. Okay, so I don't think ISL trunking was the issue here for the private VLANs. We've got some other problem. And it does appear to be isolated to switch 3. So let's go back to switch 3 and scrutinize the configuration in greater detail. We'll do a show run here. I want to review it all. Okay, VTP mode we need as transparent. Show VTP status. And we are indeed transparent. Great. We have VLAN 200 is our primary. VLAN 400 is our isolated. That looks good. VLAN 600 is the private VLAN community. This configuration over here, I think I got in some real trouble when I did the copy paste. Yeah, I think I got in some real trouble when I did that. So I'll tell you what we're going to do. We are going to redo this. Yeah, this doesn't look right at all. Look at that. Our private VLAN community has the association command beneath it. So let's do this. Let's say no VLAN 400. Or we're going to get rid of them all. I don't trust it. No VLAN 200. No VLAN 400. All right. VLAN 600, we want to do private VLAN of the type community. VLAN 400, I want to do private VLAN of the type isolated. And then VLAN 200 is our private VLAN primary. And the private VLAN association is with 400 and 600. All right, now let's confirm. That looks better. Look at that. That looks better. And that will match what is on switch 2. So my copy paste, trying to save a little time there and messing up the order of operations and doing that, that wasn't good. All right, let's get back to our testing now. So let's go to R4. Can R4 now ping the promiscuous port? Yes, it can. Can it ping its community VLAN member, R1? Yes, it can. Can it ping the stubborn isolated port member, R5? No, it cannot. Look at that. So the private VLAN infrastructure is now working beautifully. Let's go over to the isolated device. Stubborn device. Can the isolated device ping its default gateway? Yes, it can. On the promiscuous port. Can it ping the community member R1? No, it can't. And obviously, it cannot ping the other community member R4. That would be your final test. And the private VLAN infrastructure is working beautifully across our 2 Catalyst switches. So, there it is, folks. The private VLAN configuration on some rack rental gear. You gotta love it. And we saw some bonus troubleshooting there. By the way, let's solve a little question that came up there as the final thing that we'll do in this demonstration. Let's take the link back to ISL. Because after all, if I had changed that in a certification exam environment, and it wasn't the issue, I would want to actually change it back, wouldn't I? Sure. So I'll say interface fast Ethernet 0/19, no switch port trunk ncap.1q. We'll do a show interface trunk. Once it comes back up, it's back to the negotiated interswitch link. We'll go over to R4. Can R4 ping its community member R1? No, it can't. Now again, let's make sure that this isn't a convergence issue. Wow. So we just, yep, it was a convergence issue. Look at that. Yep. So it can ping its community member and it cannot ping R5 in the isolated port. So sure enough, our private VLAN functionality is restored after switching back to a negotiated interswitch link connection. So ISL versus .1q has absolutely nothing to do with impacting our private VLAN configuration.